Routers have been an integral part of Cisco's offering in enterprise information technology for many years. Routers are the essential building block of both local area networks and wide area networks, as they provide essential functions such as path determination and packet forwarding. Routers are also a key component in security and policy enforcement, as they provide Layer 3 boundaries where access lists, route advertisements, address summarization, and policy-based routing can be implemented. The basic process of routing forwards data packets between various networks, providing a best route to the destination, and often an additional alternate route should the best route not be available. Routers provide a control point on the network by terminating Layer 2 collision and broadcast domains. This contains errors to a small portion of the network should an error occur, and also prevents propagation to other areas of the larger network. Routers are needed for functions that a Layer 2 switch cannot provide, including routing between different networks or subnets, and the creation of IP routing tables that contain best path information. Cisco routers can create a routing table from a combination of the following methods. The first method is a directly connected network. When an interface has an IP address assigned, is connected and enabled using the no shutdown command, the router will learn the subnet assigned to the interface and add it to the routing table. Directly connected routes are considered to be the most reliable and therefore the most trusted. An administrative distance of 0 is assigned to directly connected routes. The lower the value of the administrative distance, the more trusted it is. Therefore, a router will use a connected route as the best route, even if that same prefix is learned via another method. The next method is static routes. A static route is a quick and easy way to modify the routing table by manually adding routing information. Static routes typically have an administrative distance of 1 when they're pointing to a remote IP address, but it can also be configured with an AD of 0 when pointing to a local interface. Static routes are considered a viable solution for small networks or branch offices. While easy to implement, they require manual maintenance if the network topology changes, and can create invalid routes if the remote IP address they're pointing to is changed or removed. Dynamic routes are routes that are learned and advertised by dynamic routing protocols. These protocols fall into two primary categories. The first are interior gateway protocols, IGPs. Interior gateway protocols are designed to run inside an autonomous system. The next category is the exterior gateway protocol, or EGP. Border Gateway Protocol, or BGP, is designed to run between autonomous systems. Dynamic protocols are designed to update routing information when topology changes occur and therefore better suited to large networks. Implemented correctly, dynamic protocols also require less manual maintenance and are less likely to create or advertise an invalid route. And finally, we have default routes. A default route, which is commonly called a gateway, can be implemented as a catch-all when an explicit route to a destination does not exist. The default route can be manually created using a command such as shown in the example. 10.1.1.0 represents the destination network, and 10.2.1.1 is the next hop router. Another way to install a default route is to advertise it using a dynamic routing protocol such as the following example using RIP. The following are examples of how routes will be displayed using the show IP route command, which is used to show the contents of the routing table in a router. The letter indicates how the route was learned. The letter C represents directly connected networks. L represents local routes and indicates local interfaces within connected networks. S represents static routes. The letter S with an asterisk indicates a static default route. O represents the OSPF routing protocol. And D represents the EIGRP routing protocol. The letter D stands for dual, which is the update algorithm used by EIGRP.